Welcome back to This Week in Bevy. This week, we see some nice ergonomic improvements to the defaults for scene entity despawning, opt-in configuration for runtime validation of shaders, which has performance implications, and more occlusion culling in more places. In the showcases, procedural generation ranks highly as always, with more landscapes and even spiral staircases. And in the crate releases, we see more attempts at better ergonomics through a revived Bevy skybox, new config loading, and generic materials. So first off, 17.938 changes the behavior when despawning scene root instances. You would have been doing this already if you were spawning in a GLTF scene, for example. As a result of some of the relationships work, despawning scene roots despawn recursively through the parent-child relationship, which is now child of, which means that entities that were in that scene that are no longer in that hierarchy, say they had their parent removed, which is actually a case that I have in this other game where this cube can be despawned and respawned, and as a result pops out of the scene hierarchy. The good thing is you don't really need to know the details because you can choose which behavior you want. If you want everything associated with the scene root, including the entities that are no longer in the hierarchy, to be despawned, you can use scene spawner despawn instance, and otherwise you can use the regular despawn. 17.767 introduced unchecked shaders to Bevy and set that as the default. This increases performance since most shaders in a development pipeline are trusted code and don't need the runtime checks. But not all Bevy applications run trusted code, and recovering the ability to validate shaders for behavior like infinite loops is useful if you plan on running user-submitted shaders, as in like a playground-style application would. 17.824 then makes this checked versus unchecked behavior configurable, so you can choose which one you want. And occlusion culling moved forward this week. Occlusion culling skips the vertex and fragment shading for objects that are behind other objects. Being behind another object, therefore, makes it guaranteed that they aren't visible. Occlusion culling itself landed in 17.413, and this week was extended to work on directional light shadow maps, as well as the deferred rendering pipeline. And first off in the showcases, we've got SDF anti-aliasing. This is anti-aliasing and attempting to improve resolution using signed distance fields. The work calculates an SDF from a pixel image, and you can see the resulting SDF here. Next up, we've got a headless Bevy Renet on Kubernetes. The Bevy Renet multiplayer example was made headless, put into a container, and deployed to Kubernetes. This one is over on GitHub, so go check it out if you're interested. I also think there's going to be some blog posts in the future from this author on the topic of networking and multiplayer, so look forward to that as well. And next up, we've got some procedural terrain generation with level of detail and mipmapping implemented. The render distance on this one is approximately 128 kilometers. Next up, we've got another GitHub repo. This is a fork of Tantan's greedy meshing repo. The project updates Bevy to 0.15, works on de-hardcoding the block types, and adds transparency. And then we've got student tank battles. This is an educational tool for students to learn Java, data structures, and algorithms. The game runs on a Rust server with Bevy handling the game logic. It supports multiple lobbies, allowing several matches to run simultaneously with players and spectators. There's also a spectator client in Bevy that connects to the server, receives game state updates, and renders them in real time. The students get to program their own bots by writing Java-based AI for tanks, using a custom library that was built to handle all of the networking. The student focus will be on strategy, navigating, targeting, and outmaneuvering opponents to win. And next up, we've got something a little unintentional. This is a set of grid cells that turned into this unintentional creation using these green and blue cells that's kind of reminiscent of a kind of goopy, semi-attractive water. And next up, we've got a showcase of Bevy HTML Lite's new behaviors, including font sizing and observers. This is 3D Signage working in a Ratatui-based Unicode renderer, including zooming in and out. And this procedural staircase can use variables to control the height, radius, number of steps, and stair width. Colliders for the staircase are still a work in progress. Next up, we've got an early prototype of a grid-based pathfinding for a 2D colonist simulator game in the style of RimWorld or Dwarf Fortress. The implementation features box selection, right mouse button click and drag, and avoiding obstacles en route, though the units don't avoid overlapping with each other yet. And this mission control style view of Earth isn't using shaders, but is rather drawn using an unlit black sphere and gizmos, specifically the line strip gradient. This visual is for a game about designing trajectories for spacecraft. And in Torp, the player can now move objects from one spot to another. Moving objects have a chance to break, which reduces with the skill of the citizen carrying. In this case, a number of characters walk into this house and take a bunch of planks, I believe, and drop them off. And then we've got web slinging through the web. This web slinging implementation that we saw last week is embedded in a browser extension that finds all the text on a web page and adds a collider for each letter. And Noumenal gained ray-traced smooth surfaces this week, including correct depth for rounded shadows. These images showcase switching between flat shading to show the difference at low detail levels. And here we see some procedural tree generation that you can play with on the web. Press C to see the contours of the procedural tree, and press W to see the vertexes or triangles that make up the tree. And procedural dungeons are back in the next showcase. This mesh generation for a procedural dungeon includes interior rooms this week. The rooms that the stairs will form between for different levels are currently generating with their synchronized positions. And lastly, for the showcases, this is a Spherical Harmonics demo, a demo for the Mountain Bites demo party. This demo renders an oscillating shape made of spherical harmonics by passing coefficients with a storage buffer. A video of the session is available on YouTube, and the source code is also available on GitHub. And that brings us to the crate releases for the week. First off, we've got Bevy Config Stack v0.1. This is a configuration plugin for Bevy that can load RON files and store them as resources for access. It comes from, as many of these kinds of crates do, repeated usage writing this code over and over for various games, abstracted into a crate. Next up, we've got Bevy Trench Broom v0.6. This is a Trench Broom, which is a Quake level editor, and now Eric W Tools, which is a Quake level compiler, integration for Bevy, including the ability to load .map and .bsp files. 0.6 brings a massive API overhaul, BSP support, lightmap and irradiance volume animation via compute shaders, and a better material system via Bevy Materialize, which we'll talk about in a second. Speaking of Bevy Materialize, this is a crate for loading, storing, and applying type-erased materials in Bevy. You can see a familiar new type wrapper, similar to the Mesh Material 3D, loading a material asset that is written in TOML. In this case, we've got a standard material with some of the attribute sets, and a bit more. And next up, we've got Bevy Dyne Component. Bevy supports dynamic components, or components created and registered at runtime instead of statically, by implementing the component trait. This dynamic component approach includes guarantees you need to uphold using unsafe. Bevy Dyne Component incurs a small amount of runtime overhead to track this work for you. It works by registering a new dynamic component, patterned after an existing one, and then ensuring you're always using the correct pattern to interface with it. I've been working with reflection a lot lately, so this kind of crate is super interesting to me. And then we've got something that's probably a little bit easier to understand, Bevy WebSocket. This runs a WebSocket server inside of your Bevy app. Really a case of does what it says on the tin. Following that up, we've got Fade Gen, which is intended to work with Seldom Pixel. Fade Gen generates filters that fade to the given color, and of course, as we mentioned before, is intended to work with Seldom Pixel. And then we've got Bevy Animation Graph 0.6. Bevy Animation Graph is a third-party animation library for Bevy, implementing Unreal Engine 5 style animation graphs, and which comes with an eGUI-based editor. 0.6 introduces dynamic animation node registration, which allows you to create your own animation nodes by implementing the node-like trait. 0.6 also brings better debugging tools, new nodes, and more. And finally, we've got Bevy Skybox. Bevy Skybox actually existed before Bevy's Skyboxes did, and now it's being revived on top of Bevy's Skyboxes as a quick and dirty way to take a Skybox network that you found and use it to make your prototypes prettier. There are some assumptions about what the Skybox needs to look like in an unwrapped cube form, so if you've been having trouble with Skyboxes, maybe check this crate out for the ergonomic improvements. And getting down to the devlogs, this is NPC Simulator. This devlog is a progress report on a game in which you are the NPC and need to define what wares you will or will not share. And this is the fourth devlog of To Build a Home, the upcoming 2D life simulator inspired by The Sims and Dwarf Fortress. This time, To Build a Home's authors talk about characters having responsibilities from watering plants to going to work. And that's it for this week. As always, we have all of the merge pull requests on the website if you want to go check those out. And with that, I will see you next time. Have a great rest of your week.